Now we're going to look at graphing polar equations by plotting points. So to graph this from the book, to graph the rectangular coordinate system, we constructed a table of x and y values. But we don't have x and y now, we have r and theta. And r is typically written as being dependent upon theta. So to graph in the polar coordinate system, we construct a table of theta and r values. We enter values of theta into the polar equation and calculate r. However, using the properties of symmetry and finding key values of theta and r means fewer calculations will be needed. So finding zeros and maxima to find the zeros of a polar equation, we solve for the values of theta that result in r equals 0. And to find the maximum value, substitute values in for theta into the equation to determine the maximum value. So let's take a look at example 2 here. We want to graph, find the zeros and maximum of absolute value of r for r equals 2 sine theta if necessary to find the polar axis intercepts. So if we say, where is 2 sine of theta equal to 0? That'd be r equals 0. And this would be when theta is equal to 0, pi, and 2 pi. Now if we look at trying to get the maximum values, and this is just the first set. This goes on forever, by the way, ... Okay, so let's go ahead and come up with some values. So let's go 0, pi over 6, pi over 4, pi over 3. Looks like my graph has got pi over 6 to pi over 3, so I'm not going to do the pi over 4 then. So let's just do pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and we'll go to pi. Now I usually go 1 past that, so 7 pi over 6, to see if it's overlapping. Then we'll look at r. So maybe I should write it this way. So we're looking at, this is going to be 2 sine of 0. That's 0, not theta. And that's going to be 0. Then we have 2 sine of pi over 6. Well, sine of pi over 6 is 1/2, so that's 1. Then we have 2 sine of pi over 3. So that's going to be 2 times the square root of 3 over 2, which is square root of 3. And we have 2 sine of pi over 2. So 2 times 1 is 2. We have 2 sine of 2 pi over 3. And that's going to be 2 times square root of 3 over 2. So square root of 3. By the way, that's approximately 1.71. Approximately. I guess 1.73. Then we have 2 sine of 5 pi over 6, and that's going to be 2 times 1/2, which is 1. Then 2 times sine of pi is 2 times 0, which is 0. And then 2 times sine of 7 pi over 6 is going to be 2 times negative 1/2, which is negative 1. So I want to graph these and see what this is starting to look like. So we will start at 0 of here, and then at pi over 6, which is this line, we're out to 1. And then at pi over 3, which is this line, we're at 1.73, so right about there. Then at pi over 2, we're at 2, then 1.73, and then 1, then 0. And then for this line, 7 pi over 6, we're to negative 1, so we're back up there. So it is going over itself. So there it is. That was kind of fun, right? You can always use decimals to graph these too, and they'll go much faster, but it's important to see where these are coming from. Okay, we'll stop with that.